Hi, welcome. This is a demonstration for the tool Mesosphere DCOS as part of the Tech Talks in the CSE 591 DevOps course. Mesosphere DCOS is a data center operating system which is deployed on a cluster, and it is used to do various tasks such as provision a cluster, manage different jobs in the cluster, and to etc. So the main functionality of Mesosphere DCOS is to act as the central control which schedules the jobs, completes the jobs in the data in our cluster. So in our example currently we'll be looking at how to provision a cluster on AWS and then how to schedule jobs on this. Mesosphere mainly consists of different frameworks such as Marathon, which is a framework used to schedule jobs, Chronos, which is a replacement for the cron jobs. This is also used to schedule different jobs on the data center cluster. Mesosphere mainly uses the Apache Mesos, which is a distributed kernel, and Mesosphere DCOS is built on top of this. So in this demonstration, let's take a look at how to step by step build a cluster on AWS. So the first step in order to do so is to sign up with AWS, which we have already done in this case. The next step is to follow the instructions in this link provided here. So once we click on this link, we're taken to a page where we have the instructions. So the first step is to create an AWS EC2 pair in that region, which we've already done in this case. So and the next step is to create a DCOS cluster. So this is automatically done through the use of the AWS template. So if we click on this, so Mesosphere offers two configurations. One is when in which there is a single master, and the other one is for a highly available configuration in which there are three masters for fault tolerance. So currently in our demonstration we are just selecting one master. So since the template has been auto selected, just click on next and give any name for the cluster, and also make sure that the key pair which you've created previously is the same one as the one you're selecting now. In our example, we're creating one public slave and 5 private slaves. These numbers can be changed as per the user requirements. So just accept and create the cluster. So if you take a look at the clusters in progress, this is currently in progress. So it takes about 10 to 15 minutes for the cluster to be initialized. So now we can see that the creation of the cluster has been completed. So if we go ahead and refresh this on the outputs tab, we will be able to see public DNS for the public slave DNS server, and also for the Mesos master. So the next part is to install the DCOS CLI on our system. So we have already installed the DCOS CLI on the system, but then one of the important parts is to point the URL of to our current master. So if we go ahead and go to the URL of the master in our current for our current cluster, we'll be able to see that we can reach UI. So yeah, just go ahead and skip that. Yeah, so we will be able to reach a UI wherein we can see the different aspects such as CPU allocation, memory allocation, and task failure rate, and total number of tasks. We can also see the total number of services currently scheduled. We can see that the Marathon service is idle right now since there's no tasks scheduled on it, and we can also see the total tasks in CPU and everything on the number of on total number of tasks on all the nodes. So this is a very helpful UI through which we can monitor all the required settings. So in order to point the DCOS CLI we use the install.sh which was provided by them. So we use install.sh current folder, and then we also need to point it to this master. So let's just go ahead and do that. So there also needs to be an HTTP for that, but so once we do that, it points, so it goes through the process of pointing this DCOS CLI to our current URL. So it changes it from the previous one to the current URL, and it changes a few of the other settings. So just go ahead and type it in. So once we execute these commands, you can see that DCO, it has been correctly installed. So this is the second step, wherein we have installed the DCO CLI and pointed the URL to our current Mesos master. So the next part is to deploy a sample web application. So right now we just need the nginx.json file. So let us take a look at the contents of nginx.json. So the contents of this file point that, like, here we specify an ID, and here we specify an image which we are currently downloading from the Mesosphere Docker Hub. And so this image has as a Docker file which downloads an nginx server onto the system. So we'll be starting the server on host port 80, and the most important thing is we also give it the role that this should run on the public slave, so that this is visible to us. Essentially, Mesosphere does not give us access to the private nodes, it only gives us access to the public nodes. So we need to run this on public so that we can see the output of it. So this is the nginx.json, and we'll go ahead and run this command to add this to the this marathon app to our what had happened was we added a previous marathon user previously, and so that URL was still remaining. So we can remove that using unset marathon URL. And again, once we do the app add nginx.json, now it has submitted this app to our Mesosphere. And so if you go to marathon and look at the details in the marathon UI which is provided by Mesosphere, just give it a second to load. And so right now we can see that nginx, the app has been deployed to here. So if we go to the public slave IP, so right now it has still not been deployed, since it takes maybe a few couple of minutes to fully deploy the nginx app. So we can see the status and other required settings of the app in the marathon UI. So as you can see right now that this indexed this content which we have provided in the nginx index.html in the Docker file is currently being shown on this public slave, and while we access it on its public DNS. So this is how we deploy a basic web app to the Mesosphere cluster. So now we have finished the first part. So now let's go ahead and just stop this app. So here it says ID of the app. So in our case, the ID of the app would be /nginx. So now if we go back here and see, there are no tasks currently running since we have just removed that. So let's go ahead and take a look at how to deploy a Cassandra instance and install an app on it. So the next part is to install the Cassandra package. So Cassandra comes as a package in the Mesosphere universe. All we need to do with it is to go ahead and install the package in our current cluster. So once I do DCOS package install Cassandra. Just go ahead and type yes. So it's currently installing the CLI and other settings for the package. So as you can see now, it has submitted this service in Mesosphere, and in Mesosphere we can see that this has currently been submitted as a job, but its current status is unhealthy, and it takes about around 10 minutes maybe to deploy the Cassandra cluster totally. As you can see, the CPU utilization has also gone up. So now we can see that the status of Cassandra has changed to healthy, which means that Cassandra has been successfully installed on our cluster. So let's go ahead and deploy the Oinker web app. So currently we have finished up till this step. Next, so the Oinker application is a web application which we deploy on our private nodes. But in also order for us to have some visibility, we use an Oinker edge router which proxies all the data to the public slave node, and it also takes the data and stores the data on the Cassandra instance as well. So this is a web application which is stored on Cassandra and works on the internal private nodes, but we'll be able to view it from the public slave nodes as well, since there's an Oinker edge router which proxies the information. So in order to deploy the Oinker application, just go ahead and run this command. So if we actually take a look at deploy oinker.sh, we can see that we just get 2 files from the GitHub, and we just add those files to the Marathon instance as new applications. So if we go ahead and just deploy this, we can see that it downloads the required files, and it also runs the commands to add them as jobs. So now if we go back to our master and see whether the jobs have been added or not, it takes some time in order for the tasks to be added. So as we can see, the tasks have been deployed, so we can take a look at what tasks have been deployed so far. And so these are the Oinker applications, 3 instances, and this is the Oinker router application. So now that these tasks have been deployed, we can go to the public slave node and see that the Oinker application is running here. So we can just go and type the following commands to see that this is happening. So whatever we enter into the web page can be seen here. So this is the Oinker application, and this application is currently hosted on our cluster and Cassandra. So another useful thing which we can do is to scale up the instances as scale up and scale down the instances as and when required. So if we take a look at this command which is used to update it, we can just try using this command and change the ID of the app to Oinker. So before we do this, we can take a look at that there are currently 6 tasks in Cassandra and 5 tasks in Marathon, and if we take a look at the nodes, there are about 3, 1, 2, 1 and 1 tasks on each node. So once we do this, the number of tasks increase, since we increase the number of instances, so the number of tasks on each node increases. So if we take a look, so we can see that the number of tasks has gone from 3 to 4, and correspondingly in other nodes as well, and it has already also increased here. So if we take a look and we open the service right now, we can see that the number of deployments is being increased from 6 to 8 currently, which is our final 8 is our final number. So, that takes maybe about 30 to 40 seconds to fully deploy all the instances, and we can see that even during this the application is fully functional. So even if we type any of this, we can still see that the data is being sent here, and so the deployment is still currently taking place, and it takes a little bit of time. So now we can see that the deployment has taken place, and once we see this, like once we open the UI, we can see that 8 out of 8 instances have been deployed. So this is a useful way in which we can scale up and scale down. So suppose if we say we decrease the instances to 3 again. So right now it's still updating this app. So now we can see that it has created this deployment. It was previously still logged in for this app, but once that has been finished, we can see that it has created a new deployment. And if we go here, we see that the number of tasks has reduced to 5, and we can see that the number of instances has also reduced to 3. So you can see that it has reduced to 3. So this is a main application of Mesosphere, wherein we can scale up, scale down, and perform various other tasks on various applications. Apart from the normal Marathon applications, we can also install different Hadoop or Spark jobs on this as well. So in this way, Marathon is a very useful data center operating system tool. This ends the demonstration for this tool.